Okay, we're looking at your rational numbers, little concentric rectangles thing.
It's called the number system.
Thank you. It is the number system. We need my camera to work. Thank you. The definition of a rational number. According to your notes, please raise your hand and tell me what a rational number is. Yes.
Any numbers that can be right as a fraction where make your 0 on the 5.
Any number written as a, what's a fancy word for fraction? That's its triplet, one of the triplets, fraction, decimals, and percents. What's another fancy word? Ratio. Any number written as a positive or negative ratio. Including, who are the triplets? Fraction, decimals, and percents. We're mainly going to focus on fractions and decimals for our rational numbers. Please write that down there, but give yourself some room to include examples. I need you to stay focused. Integers. This will be up here. Integers are called what? Or the definition of integers? Positive and negative, what kind of numbers? Positive and negative whole numbers. Whole numbers. What's the definition of whole numbers? Yes. What is the definition according to your notes? Yes. Any number without a partial value. What do I mean by partial? What's a partial number? A fraction or a good. A fraction or a decimal. Okay? Or a percent. Natural numbers. What are those called? Yes. Counting numbers. All right. No, we do not count like this. 1, 2, 3, 4, 4.5, 5. That's not natural counting. We don't say 1, 2, 3, 4, 5, 5 and 1/3, 5 and 2/3, 6. That is not natural counting. So every number is not a natural counting number. All right. Now I need examples of counting numbers. What were the numbers that I started with?
1, 2, 3, 4, 5, 3, 4.
And so on. What number do we include in the whole numbers subset?
0.
0. Good. How else can I write a whole number?
1 and 2.
That's not a whole. I want no partial values, sweetheart. Yes. 5 over 5. 6.0 is a good and the other example. This is still whole. It has no partial value. This has no partial value. 100%.
Got that right.
That's one whole. Last one. Yes, Dylan. 14 over 1 works. Because 14 divided by 1 is just 14.
So would it be improper? So would it be improper?
It's still a whole number. It is an improper fraction and a whole number. All right, integers. What are integers?
Negative 4.0.
Okay, listen. What numbers do I include in this group that are not whole numbers? That's what I'm looking for. Yes. Negative 15 works. Give me enough. Okay, stay focused. Do not respond to his answer. That's when extra chatter starts. I don't need that, neither do you. You have a test in less than 2 weeks. Stay focused for the 3rd time. Yes. Negative 24 over 12. What'd you say over here? Negative how much? 100. Negative 24 over 12. Negative 100. It can be but I want to really include the numbers that cannot be considered whole numbers. So I need it to be negative, and I need it to be in another form. Yes. Negative 4.0. It's still a whole number. Okay. Last one. Yes. Negative 21 over 1. Still works.
I won.
Okay, really the last one for real. Why don't you put 100 over something else?
No.
Yes, 50 works. Negative 100 over 50. Rational numbers. Now I can consider the who's. Fractions and decimals, which are what? Give me an example.
Oh, 53%.
What else?
8.87.
8.87. Give me some repeating decimals. Give me some negative repeating decimals. Give me a fraction that's less than 0. Negative 1/3. Okay, that's enough. We got to move on. Irrational numbers are not really necessary for our test, but I'm going to tell them to you anyway, give you the definition. They are infinite, non-repeating decimals. What? No, it's never released before it's given. Such as pi or the square root of 2. Please write that down. It's infinite. No, pi goes on and on and on forever. Okay, ladies and gentlemen, have you finished writing this down? All right, now turn on to your fractions and decimals paper, the pink one.
Mine's upside down.
Are you staying focused? Did you watch my video? Okay, then you would, I'm not responding to that because you did not watch my video. Adding fractions and subtracting them. The steps are fairly similar. The operations is what changes. I don't know why I hear other people talking while I'm talking. Find blank blank and find blank blank. When I'm adding and subtracting decimals, what is needed? Yes, what about the numerator and the denominator? You should not have glue right now unless you're touching something up. Are you missing like a corner or something? Or are you about to glue a bunch of things down? Come on, I need your answer. We're wasting time. We have a lot to get through, sweetheart. Okay, do it quickly. All right, we have denominators and numerators and fractions. Great, but what do I need to find in order to operate with adding and subtracting them?
Question.
Yes. Not multiple, but starts with a D. Denominator. Least common denominator. Same thing over here. Least common denominator. Bless you. Add the blank and blank. Subtract the blank and blank. Only word here that's changing is the operation. What am I adding? What numbers do I have down here? Add the numerators. Subtract the numerators. And the who's and the who's. Nope, I cannot add or subtract the denominators. What numbers do I have down here? What? Good. Whole numbers. And subtract the whole numbers. Blank if needed, blank if needed. Simplify. That is for all four of these operations with fractions. Simplify, 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 and simplify. Okay, looking at multiplying and dividing fractions. Convert any blank or blank blank to blank. Convert any blank or blank blank to blank. The first step are the same for multiplying and dividing. What do I need to convert? Call it out. No, I don't want to convert fractions into decimals when this is talking about fractions. I can't change the form necessarily because it might not be friendly. Like this 6/7 is not going to end at one decimal place. Yes. Whole numbers. And what else? Whole numbers or mixed numbers. Good. To what? Improper. Excellent. Improper what? Fractions. Multiply the blank and the blank. Yes. Which are what? What are they called in numerator and denominator? What's this step over here, though, that they have before we multiply the numerator and denominator? Who, what? I have to flip. What do I have to do before I flip? Keep, change, flip. Numerator, denominator. All right, those are your fraction operations.